Okay, thanks very much. Really glad we've got a lot of people here. This is going to be exciting. I just got a question. Do we have a list of topics? And yes, these are the absolute first steps with Arduino. I'm going to show what it is, how to get started with it. We're going to light up an LED, and we're going to add a push button so we can control that LED. I'm just going to give you a real brief background on who I am, and going to jump right into this. I don't have a single slide for you. You'll be all happy to hear. This is going to be extremely hands-on. So, and we do have a question about downloading drivers, and someone's seeing no video. That's right. I'm not doing any video just yet. I will be in a moment. So, in fact, I could go ahead and start that while I'm talking. So I'm Brian Jepson. I'm a senior editor here at O'Reilly. I also contribute to Make Online, and when I'm not doing all of that, or when I can combine it with something I'm doing, I like to hack on Arduino in my spare time. So things are running a little bit slow for me on my end, but I'm working on sharing my desktop with you, and I will do that. Here we go. Now, so okay, I see.
Looking good. We got it.
And it's working. Great. So, Arduino is, as described on their website, an open source electronics prototyping platform. And when I explain that, I like to go backwards through the explanation. And by prototyping platform, what I mean is that it's something you can actually use to invent new things. We like to talk about sketching out ideas in hardware, and I'll come back to that word sketch shortly. The idea is that you can take your digital ideas, or ideas that maybe you're used to thinking of digitally, and express them in the physical world in a very tangible way. And that's where electronics comes in. There are a lot of cheap, easy-to-use sensors that you can get. And just a reminder, we are going to be making the video available later. With electronics, you can work with sensors, things that can sense light, temperature, or even just a simple button press. And then these things called actuators, which are things that create output, like a light or a motor or any sort of thing that creates a reaction in the physical world. But one really important part is that Arduino is open source, and it's based on open source technology, which means that it's very easy for people to extend, expand, turn into new things. Is anybody else getting some problems with the audio? I did see one comment.
What I was saying, Brian, is it usually happens when something's competing with bandwidth. So if your audio is choppy, it's probably on your computer. You may want to close the apps that interfere with it. And like I said, refresh the window. That will usually take care of it.
Yep. So everybody is reporting in now with great sound. So if you are having a problem with the audio, just make sure you're not running anything, or quit out and go back in, open a new window. If you're on a network where you can plug into an Ethernet and turn off your Wi-Fi, that's going to really help a lot, especially if you're in an office where there's a lot of people trying to use the Wi-Fi at once. So we do have a few people who are having problems with audio. We will have the audio available later if it's not working for you. So Arduino is open source, and it's based on open source technologies that have been around for a while, and that's made it possible to run on all sorts of platforms. And that's one of the real strengths of Arduino, is it allows people to do this sort of electronic programming, whether they're on Mac, Windows, or Linux. What I'm going to do right now, sorry, one of the comments just made me laugh. Little World Cup joke there. So I'm going to switch over to the camera now, and I'm going to show you what's inside the kit that we're making available at a discount for this talk. So I will be switching over and back with you in a moment. So this, you can see on the camera, is our Getting Started with Arduino kit. And yeah, this is a little bit of a sales pitch, but in order to do anything with Arduino, you definitely need an Arduino. And we're not the only source of Arduino, so I'll tone down the sales pitch a bit. This is the Arduino board itself. I'll turn it right side up for you. And this is really the basic thing that you need. You do need this and a USB cable. The great thing is it uses that same type of USB connection that you would use with a printer. And so every time you bought a printer, you probably had one of these USB A to B cables, and this plugs into your computer, and then you can program it from the computer. And from there, you need electronic components, and that's why we put together this kit. And I'm actually just going to take out the parts that I'm going to use for this. You can find out plenty of info about the kit on the website, and if you decide to order it, or you can, if it's more convenient, you can look at the parts and get them wherever you want. We do have a book that's in the box, Getting Started with Arduino, and in fact, all the examples that I'm going to be doing are pretty much lifted right out of that book. So I mentioned earlier that the USB connection is how it actually talks with your computer. And so I've conveniently got a USB cable over here and an Arduino over here. And once that plugs into your computer, what you'll be able to do is write programs and upload them to the Arduino. And then it starts doing things. It's almost like a computer connected to your computer. Well, it actually is a computer connected to your computer. It's not like it. So I want to switch back to the desktop and show you how to program this thing. So this will just take a moment. There might be a brief lag, but I'll be right back with you. Okay. And I'll just be switching over to my desktop. So the first thing that you're going to need to do to work with Arduino is to download the software that comes with it. I'm running on a Windows machine right now. I actually do most of my programming on the Mac, and there are versions of Arduino for Mac, Linux, and Windows. And so the Arduino site is arduino.cc, and if you click on the download page, you'll come first to a license agreement, and then the downloads for it. There's a version for Windows, Mac OS X, and Linux. And I've got the Arduino zip file from for Windows here, and it looks a lot like this on the Mac as well. You basically open up the zip file and drag it somewhere in your computer. I just put it in the C drive under Arduino-0018. It defaults to using the file name. And the installation for Linux is a bit more involved, so you'll see some instructions for that on the website. But on the Mac and Windows, it's drag and drop, and then you just double-click on the application. On versions of Windows prior to Windows 7 and on Mac OS X, you are going to need to go into the drivers folder and install the drivers for it. In the case of Windows, you just CDI USB drivers, and it looks like your typical set of drivers because it is. On the Mac, I believe there's two sets of drivers, one for Intel Macs and one for the older PowerPC Macs. And typically, you may have to do a reboot after you do this. On Windows 7, you just plug it in and it finds the drivers off Windows Update. Someone just mentioned, I saw a comment fly by, that things are very easy to install under Ubuntu Linux, and that's really great. I've had a lot of luck getting it installed on a variety of Linux systems. My favorite, I just saw a question about Fedora. I have gotten it running on the XO laptop. It required a little bit of tweaking, and it was a couple of years ago that I did it, but that's Fedora based. But there is a forum on the Arduino website, and if you're having trouble with a particular version of Linux, some searching there should be able to help you out. So I'm going to load up the Arduino IDE right now, and I'm going to show you the most basic Arduino, one of the most basic Arduino demos, which is called Sketch. So let me double-click on Arduino. And things run a little bit slow on my computer because I'm running Arduino and encoding my voice as I talk to you, so the Adobe Connect streaming stuff and Arduino are duking it out for control of my CPU. So this is the first thing you see when you see Arduino. And everything that you would need to install or would think you would need to install, like a C compiler and all these other things, they're all hidden underneath the hood. All the compilers, all of the programmers, all of the things that normally would have to mess around with when you're doing embedded type development, all this stuff is taken care of. So all you do is you just see a blank screen and you can start writing code, which is great. On top of that, you can go to the examples link under File and choose a program, and it just puts it in. I'm going to choose one called Blink, and it's under the digital section. And I'm going to close the blank window that it had opened earlier. And so this application that we're looking at is the Arduino IDE, or Integrated Development Environment. The program that we're looking at is called a sketch. That's the Arduino terminology for program. So you'll see a sketch menu up here that lets you do a lot of the things that are also on the toolbar here. So when you hear me talk about an Arduino sketch, if you're a programmer with experience on other platforms, you'll find you may be used to calling them programs or something else. So I'm just going to go through the code here. Arduino is C-based, but I'm actually going to take a real quick break here because I do see a lot of questions about where to get them. And now the MakerShed kit I showed you has a lot of stuff in it, and if you just want the basic Arduino, we do sell them on MakerShed, but there's a link on the Arduino site. Click on Buy on the left, and it shows you a huge number of retailers, and especially worldwide. That's a lot of places where you can get them. I did see somebody mention eBay, and I just want to add a comment to that. I have spoken with one member of the Arduino team who told me that actually a lot of the Arduinos on eBay are counterfeits. They are manufactured using the Arduino open source design, which is fine, but they're putting the Arduino name on it, which isn't fine. The Arduino team is very supportive of clones. Many people make clones, but if you're going to call it an Arduino and use their name on it, you have to work that out with them. If you're going to do an Arduino clone, people have names like Boarduino, Bare Bones Board, things like that, but a lot of the ones on eBay have turned out to be counterfeits. I did see somebody mention SparkFun. They're a retailer here in the U.S. They're great. Adafruit is really great. All these folks are really great. A lot of places to get it. I'm going to get back to the Arduino. Hopefully that answers questions about where to get it. Just click that buy link on the Arduino page. So the first thing you see at the top of the program is a variable declaration, and Arduino is actually based on the C language, but the libraries that support it are designed so that you don't have to deal with a lot of pointers and things that trip beginners up with C. So the first line of code here sets up a variable. A variable is just a location in memory with a name that holds a value. In this case, it's an integer variable, and it's called LED pin. It's just the pin on the Arduino that the LED is connected to, and that's going to be pin number 13. When we take a closer look at the board, you'll see that the pins are numbered. And the next part here is a method or a function or a subroutine, whatever you want to call it. It runs the first time the Arduino sketch starts, and it configures the digital pin as an output, which means you can turn it on, you can turn it off. And finally, this is all that's left of it. There's a method called loop, and this just keeps running over and over and over again until you unplug the Arduino. So in this case, what it's doing is it's first sending a high signal to the LED pin, waiting a second, 1,000 milliseconds there, and then taking it low and then waiting another second. And then the loop starts all over again, and it just keeps going until you unplug it. So this is the program. In a moment, I'm going to switch to the camera. There are two buttons you want to know about. Verify on the toolbar compiles the sketch and gives you errors if there's a problem with it. The other button is the upload button, or waiting for it to compile to see if we got any errors here. Just hover over the the upload button. This button actually goes over USB and sends it to the Arduino. Now, before you can actually send anything to the Arduino, you're going to need to plug it in. And I'm going to do that right now, and you might see Windows give some messages. And once you've plugged it in and the serial port's detected, this assumes you've installed the driver, or if you don't need the driver, if you're on Windows 7 or Linux, you probably don't need to install a separate driver. And the first two things you want to do are go to the board menu and make sure you've selected the model of Arduino that you have. So this Arduino model that I'm using is the Arduino 2009, which is the latest version of Arduino, with an ATmega 328 chip. And you can actually look on the Arduino. When I switch to the camera, you'll see a big label saying ATmega 328. There are a bunch of other Arduinos out there, including clones, including licensed versions of Arduino, and SparkFun, and other people do license it. So you'll see all of the official Arduinos listed here. If you're using an Arduino clone, the person you got it from will tell you which version of Arduino it's compatible with. So you'll have to check that documentation. Second, you're going to want to choose your serial port. Now, I'm running what we call a legacy-free PC at the moment, so there's no serial ports on it. But when I plug the Arduino in, I get a port called COM8. Now, the problem you might have is if you have a bunch of serial ports, maybe you've got a Bluetooth device that acts as a bunch of serial ports, or you're on another type of computer, you might just want to click off the menu, unplug the Arduino, give USB a second to settle down, and then go over to the serial port. If you have other serial ports, you'll see them listed here, and by process of elimination, you can tell which one was the one that changed when you plug the Arduino back in. So now I've got my board configured and my serial port configured. I should be all set to upload. So I'm going to take a moment and switch over to the camera, and then I'm going to show you what happens when you upload an Arduino sketch. This will just take a moment for me to do the switch over. Okay, so here's the Arduino, and as you can see the model number printed on it. And I see some comments that the webcast is off again. That's likely to be temporary because there is a delay. Can anybody see me? Okay. There's usually a few second lag when I switch over to the video. And in fact, I'm coming to you from backwards in time. So, on the Arduino, you can see the model name, 2009, and you can also see the label on the chip. That tells you what kind. Let me see if I can zoom in a little more without it getting too blurry. Now, I'm going to switch over to the Arduino IDE, which you won't be able to see. And I'm going to click that upload button. And it does take a little while on my computer because my computer's a little bit slow. And just because it's running many things at once. But shortly you should see a bunch of lights flashing on the Arduino as the sketch gets uploaded. There it goes. And they're labeled TX and RX, which is an abbreviation for transmit and receive. And so once that's happened, the Arduino sketch starts running. And what it's doing is it's just blinking the LED. Now I mentioned earlier that there are numbered pins on the Arduino and that we're sending a signal on pin 13. Arduino has an LED, the new models of Arduino, the DHE1000 and 2009, have an LED connected to pin 13 so that you actually don't even need to connect an LED into the Arduino to see the blinking. But in a moment I'm going to show you how you'd hook the LED up to the Arduino, so if you wanted to work with some off-board LEDs. So we've got it on there, we've got the lights blinking, and what I'm going to do now is zoom out a little bit and bring the breadboard out. Now I was just asked if light L is the same as pin 13. That's correct. And we had another question, are you using serial or USB? I hate to say this, but the answer is yes. Here's what happens. The chip next to the USB port where my finger's pointing, this chip right here is a USB to serial converter. And it actually does more than that. It also passes through the USB power 5 volts to the Arduino. So what's happening is the USB port gets plugged in and it looks like a serial port. This happens with a lot of other devices. Some mobile phones do it, most GPSs do it. A lot of the times you don't really notice it until you go to do something like we're doing, which is to actually program the device. So it is a USB connection, but from the software viewpoint, it's serial port. So now what I'm going to do is I'm going to go hook up another LED to it, and we'll see it shortly blinking along with the one that's on the L light, pin 13. So I've got the hookup wire kit here that comes with the kit, and I'm going to pull out a couple of pieces from it. I can actually move things down here a little bit and zoom out. We'll be able to see more of this. So I'm going to do two things. I'm going to be taking power and I'm going to be taking ground from the Arduino board into the breadboard. Now, a breadboard is really important for prototyping, and it can also be a little confusing. It looks a bit like a cribbage board, and it has rows and it has columns. The orientation might be a little confusing, so I'm going to actually avoid rows and columns. I'll call this a power bus. It's a big line that goes down the side of the board, and there's one pin, one set of pins for ground or negative, and one set of pins for positive. The positive is colored red, the ground is colored blue, although black is often used. Now, if I plug something in anywhere here along, say, the negative side, anything else that I plug in along that line is going to be connected to it. Same thing goes for the red. Anything I plug into that and anything else I plug elsewhere, they're all going to be connected to each other. And then that brings us over to here, and these are all connected going in this direction rather than that direction. So if I plug a component in over here, say on row 40, anywhere along here, anything else I connect there is going to be connected to it. So what I'm going to do first is I'm going to take ground from the Arduino. And the ground pin, let's see if I can zoom in enough for you to see it.
Well, no, that just got very blurry. Here we go. The ground pin is right here. And if you have your own Arduino or look at a close-up photo, you'll be able to see it better. So I'm just going to connect this anywhere along the blue line here. And so now anything that plugs into this is going to be grounded. Next up, I'm going to take what turns out to be a positive voltage from the pin. Hey, that's a good idea. Point at dots with a pen instead of my finger. So, may even have a better pointer, but this will do for now. So here's the ground pin on the Arduino, and here's the ground on the breadboard. Now I'm going to take pin number 13, which is sending out a positive voltage, but I'm not going to hook it up to the red line here because that's just used when you want to send a constant 5-volt voltage to power things. This is more, let's think of this as a signal coming from the Arduino. So I'm going to just hook it into any one of these rows here. And almost done, almost done. What I want to do now is I want to grab an LED out of the kit. And it comes in the bag of parts here. First one that fell out was a blue LED, and I'm just going to talk about LEDs real quick. When you look at an LED, and here it is, I'll leave it on the board. Let's see if we can see it okay. There's a long pin and a short pin. The long pin goes to positive, and the short pin goes to negative. The reason that's important is that an LED is not so much, it's not a light, even though it gives off light. It's not a filament, you know, where you run current through a regular light bulb. It just doesn't really care what way it's going through because it's just starting a controlled fire there, basically. And so what I'm going to do is I'm going to plug one end of the LED into the ground and then the other just into a part of the breadboard where I'm going to connect the sensor to later. So putting the short end into the ground bus. It's usually easier if you spread out the wires. And then I'll put it over here. I've almost got a circuit, but it's not quite finished yet. So out of the component bag, I'm going to grab a resistor, and as the name implies, they resist the flow of electricity. I want to do a 1 kilo ohm resistor, and these are the ones that are labeled brown, black, and red. And I see I'm being reminded in the chat that the little holes in the breadboard are called points. Thank you, Gareth. And I'm going to use this resistor to bridge the connection from the positive wire in the LED over to the signal coming from the Arduino. And now you see that both lights are blinking at the same time. The resistor's there to keep the LED from burning out. In case you're wondering why it's there, LEDs generally don't like to be given 5 volts. And although previous models of the Arduino did have an inline resistor on pin 13 just to facilitate this sort of testing, when they added the little LED on the board, they gave that a resistor and now allow the full voltage to flow off the board and into the pins. So right now, I want to just do any Q&A that people have about what we just did here and save the general questions for later. So I'm going to just take a break. And if there's any questions, let me know. Here's a question. Is it always a 1 kilo ohm resistor with an LED? And no. In fact, probably would have been fine with a 220 ohm. There are formulas for calculating the proper LED resistor to use with an LED, and I know that Gareth is there attending, And I'm pretty sure we've blogged something on this before, and I think there's something on the Evil Mad Scientist site about that. So if you want to be absolutely perfect with your choice of resistor, knowing what type of current you have, what type of voltage, what value of resistor you have, the spec sheet, you can actually calculate that perfectly. So we had a question, can I take the resistor out and see what happens? And yes, I can do that, and it actually probably won't burn out, generally doesn't. And there was another question about the flow of electricity, and I'm going to describe that. I'll do that right now. I'll describe that very conventionally. And this doesn't actually map to the way that electrons really flow. They go backwards to our actual thinking. We generally think of a positive side of the voltage as where the power comes from. The positive side is pin 13 on the Arduino. So it's going into the resistor here because pin 13 is connected to this point on the breadboard, and the resistor is connected to a point that's on the same row. And let me just get the LED out of the way so it's not quite so blinding. So from there, it goes through the resistor, it resists some of the power, and gives less to the LED, and then so the resistor goes into this point, the LED goes into this point, and then the current flows through the resistor and finally connected to ground and to ground. And that's kind of the conventional explanation of how the power moves through a system, and you'll generally see schematic diagrams with positive on top and negative on the bottom, so it's a fair way to think of it. And now I did get a request to move things around a little bit so you could see it from different angles, and so I'll just play hand model for a minute. And finally I'll zoom in real close with it. All right, and we did get a link to an LED calculator, ledcalc.com. If you're not keeping an eye on the chat window, please do, because it's a goldmine of information. So, and the current coming from the board, I don't remember off the top of my head. It is listed either on the Arduino site or in the spec sheet for the chip that's used in it. If anybody, there's the voltage, but if anybody finds out what the current is and what kind of load is it'll tolerate, please add it to the chat window. So, next step, I'm going to add a push button to this, and I think before I do that, I'm going to just switch to a different color, slightly less blinding LED. And I think that should look a little better, especially if I bend the leads away. And we just had another question. Will those resources explain how to identify the different resistors? There are two ways to identify resistors. You can go online and find, thanks Alberto for posting the current info. You can go online and find a resistor calculator, or you can just grab a multimeter and set it to a resistor mode and use it to measure. That's sort of the quick and dirty way to do it. Although the online resistor calculators are great, you can just punch in the colors and it tells you what the values are. There was a question about using a red breadboard, not a white one. They're generally the same. They're set up the same way. Some breadboards have fewer rows. Some breadboards don't have both plus and minus on one side, and so there's and also Dan just mentioned that there's an iPhone app. Yes, there are iPhone resistor calculators, and those are fun to play with too. So if you search for resistor calculator, you'll find a number of them out there. So what I'm going to do next is add a push button to this, and the push button that comes with the kit is designed to nicely snap into a breadboard and straddle the line across the center. Now, the strange thing about push buttons are it's not obvious what happens when you press it. You may wonder, is it closing the switch across this side or this side? So I'm going to tell you it's closing it across this side. So when I hold this button down, the points here and the points there where the push button is connected to are going to close and create close the circuit there, and they'll be connected to each other. If anybody's having trouble with the video or the audio, try quitting out and going back into the room. I did see somebody mention that something froze again on them. So to hook up the push button, I'm going to need a few things here. The first is I'm going to need a bigger resistor, a 10 kilo ohm resistor, which is brown, black, and orange. And the purpose of this is going to be to connect the pin that we're reading from on the push button, because we're going to connect it to a pin on the Arduino, and we're going to say, hey, what's the value you're reading here? What that's going to do is that's going to keep it from giving random fluctuating readings when the button actually isn't pushed. So for the moment, this isn't doing anything because it's not connected to anything else, but I've got the push button right here connected to the resistor through these pins here, and then it's going to the negative on the breadboard. Now next, I need to deliver some current to some positive voltage to the push button so that when you press it down, something actually happens. So to do that, I'm going to go here to the pin labeled 5 volts on the Arduino, and now I'm going to take it over to connect to the positive bus on the side of the breadboard. So now we have, at all times when the Arduino's powered, we've got negative here and positive here, 5 volts. So you don't want to create a short circuit across that, and or bad things will happen. We don't like short circuits. So the next step I need to do is connect from that positive pin anywhere along this line over to the push button pin. And now at this point, when I press the push button, it will actually create a little bit of short circuit, but nothing too bad because we've got that another nice reason to have that resistor there. So, because it acts as a buffer there. Now finally, I'm going to connect the pin that has the resistor in it to one of the sensor pins on the Arduino, and I'm going to use pin number 2. And then I'm going to go and modify the program, but let me just go over this briefly before I get into the code. So, we remember how the LED is connected. It's getting positive voltage from pin 13 going through a resistor to slow it down a bit, and then goes through the LED and connects to ground, and that's how it's blinking. Now the push button circuit is basically creating a short circuit that's passing through this resistor here. So you've got positive coming in, going up these pins into the one side of the button, and then you've got the other side going to ground but through a resistor, and finally you've got a wire going from that pin into pin 2 of the Arduino. And when you push that button, the result is going to be that the pin on the Arduino is going to get the current, and it's going to know that the button's been pushed. So these are the basics of how you would deal with a sensor on this. So now I'm going to switch to the desktop, which will take a few seconds. The screen will probably go blank and flash. And then I'm going to add some code to this to modify the button so that that it can turn the light on and off when the button is pushed.
Okay, and now I'm back with you. And you probably saw lots of things go crazy on the screen. We do have a question, why the resistor? Reason for the resistor is that without the resistor, values that are coming in on that pin are going to fluctuate even when you're not pressing the button. And so that gives the current somewhere to go when there's nothing happening. Question, is there a second feed with code? And I'm going to switch to the code now, but we can remember to put the code up after this so you can see it. However, in case anybody came in late, the code that I'm starting with here is an example that comes with Arduino that you can get at by clicking File, Examples, Digital, and Blink. So we're starting with this that came with Arduino, and just been modifying it as we go. So I'm going to make a few changes to this. And this is going to allow us to read the value of the button and change behaviors based on that. So first of all, I'm going to go up to the top. And thanks to everybody who's answering questions about resistors. Appreciate that. Or anybody has questions about resistors that are being used in this circuit, check the chat window. There's some really good stuff going on there. Appreciate everybody's help. So I'm going to add two new variables. One is going to be the button pin. So this is going to be pin number 2. And the other is going to be something to hold the state of the button, whether it's been pressed or not. Now that's just the change to the variables that are used throughout the program. You need to go into the setup and change the pin mode of the button pin input. Now we're going to be reading from that. And finally, going into the loop, I'm going to make a change here. But first, we read the value of the button with a digital read method. And then, if the value is high, we're going to light up the LED pin. If it's low, or if it's not high, we're going to turn the LED pin on. Now this could also be done just with a battery, a switch, and some wires. But the point is that you're doing it in code and you're taking an action based on a button that's being pressed. A couple of things for anybody who's new to the C language. Here I am assigning the output of the digital read method to the variable named value. And over here, I'm comparing value to a quantity known as high. High is a constant used in Arduino, but so it's got some value, but we don't really know what it is. It's defined internally within Arduino. But the equal sign performs assignment and changes the value. The double equals performs a comparison. So if I had made a mistake here and just put a single equals, this would always evaluate to true because you'd always be assigning high to val. So I'm going to keep it this way. So that is almost all the changes to the code. There's one thing, and I may be a little superstitious about this, but remembering that Arduino just keeps running things over and over and over again in a tight loop, and that it doesn't have an operating system on it, so it doesn't really have anything else to do when it's not following your instructions. So if we're just telling it to do a digital read, to compare the values, to do a write, we got rid of all the delays in there that we had when we were pausing between blinks. And so what's going to happen is the CPU is going to be busy all the time. It's going to run hot, and further, your input pins may not really have a chance to kind of settle down in between presses. So this little 10 millisecond delay is just just in there to kind of give it a chance to chill out when it's. So we've got all the code in there, and before I switch to the camera, I may as well compile it. Make sure that there aren't typos in it. Seeing some good suggestions on C programming books. It is a good idea to know C if you're going to program this. It also is helpful if you know Java, because Java is arguably a little simpler than C, and the Arduino language is actually modeled on a programming language called processing that runs on your computer, and that itself is based on Java. So that's why you don't see a lot of the complicated C constructs that you'll come across in beginning C programming books. This is deliberately kept extremely simple because the processing language itself was designed for simplicity, and similarly the Arduino language was designed, or the subset of C that is for Arduino is very, very simplified. So the point of it is to create an accessible environment like this for artists, designers, students, and hobbyists. And that's why I'm seeing some message, I think it was from Alberto, suggesting that that K&R might be overkill for if you want to learn enough C to know Arduino. If you want to go deeper in C, it's definitely a choice. Now, I saw a question there. I don't know that. I'm going to switch over and take a look at the chat history regarding initializing something to low here. Shouldn't you initialize val to low rather than 0? That's a fair suggestion. That's very reasonable. That's by setting it 0, I'm making some assumptions about the definitions of high and low, and I think it is reasonable to set that to low. If anybody thinks otherwise, let me know. But I think everything will work fine if we do that. I'm not secretly telling you that I think that low happens to be equal to 0. I think it is, but I don't know that for sure. And because Arduino hides things there, it's best to stick with the level of abstraction that it uses. So thanks for the suggestions to do that. And I'm uploading it to the board right now. And then I'm going to switch to the camera. There will be a lag. There will be some flashing. Your screen will go a little crazy. Once it recovers, but things will settle down a bit. So I'll be.
Okay. So here is the Arduino. The lights stopped blinking and nothing's going on, but if I hold down the button, the light comes on. If I release it, it goes off. Now I know that we're running short on time, so I am wondering if we should switch to Q&A, or if I should make some changes to the example to show you some more things. I'll wait for someone from O'Reilly Media to answer that. Okay, well, I think I'm going to keep going. We got at least one request to go to overtime. So I'm going to switch back to the desktop. Okay, actually I'm hearing that we shouldn't go overtime, so I'm going to switch back to my desktop and let's do some quick Q&A. Having a little bit of technical difficulty switching. Catherine, I don't know if you can switch us over to screen sharing?
Hey Brian, Catherine here. I switched us over to the screen sharing screen, but it sounds like you may have frozen. And if you did, just close the window and come on back. That'll fix whatever you need to fix. So, okay, and to everyone who wants to go overtime, I hear you, but I found from experience that as much as we want to go overtime, the people who have to leave and rush off to their next meeting usually regret, usually aren't very happy that we go on without them. So what I'll do is leave the chat room open for a while. I know, it's sad. I'll leave the chat room open for about 15 minutes after we end the meeting, and you guys can chat with each other and share some, or you can move over to Twitter. I've had people move over to an IRC channel too, so all of that works. Let me see if we've got Brian here. Okay, we do.
I think I'm back. Am I?
Awesome.
Yes.
Great. So Brian, I was just telling people that even though we're not really going to overtime, we'll go for a couple minutes for Q&A. Then we'll leave the chat window open for a while so people can talk. And people were recommending IRC or Twitter to carry on the discussion, and I'll leave that up to you guys. So
yeah,
Brian,
I'm B. Jepson on Twitter, so I'll put my Twitter handle on there.
Okay. And there are some questions I want on the notepad on the side, note 3. I wonder if you want to skim over those and see if there are any you want to answer quickly before we go.
Oh yeah, these are great.
Okay.
Alec Klein Leo asks that I say this is for testing or prototyping. And so the question is, how can I make my prototype into a product design? And that is a really, really great question. Arduino is based on a very common chip, the Atmel ATmega 328, and there are actually a number of people who have gone and taken either some of the Arduino clone modules that just are designed to either snap into a breadboard or as a module onto another board, and made products out of that. But there's also a company, Evil Mad Scientist Labs, who makes these great kits. One of them is a handheld gaming kit with, let's see, I think it's maybe like 40 pixels that are just RGB LEDs, push buttons. It's almost like a minimalist Game Boy, and it's based on Arduino, and it can be programmed using Arduino. They also have a light board with, I think, 600 LEDs called the Peggy 2, and that can also be programmed like Arduino. And so it's very, very easy to integrate Arduino into your product. And so how do you do that? Well, because Arduino is open source, you can take the board designs and simply adapt it to your own product. It's only if you want to call it Arduino that you will have to that you have to talk to the Arduino folks about licensing. So if you just say that it's Arduino compatible, that's no big deal. Now, another question is, I need to power an Arduino with a battery. How long will certain batteries last? 9 volts won't really give you a huge runtime. I usually find 9 volts is good for running maybe about 24 hours solid if you have some other devices plugged into it, maybe a little bit more. I'm trying to remember, at Maker Faire we had a few things running off 9 volts, and by the second day we switched over to using wall warts into a 9-volt power adapter to plug it into the wall, because it really does run them down. There are some LiPo batteries that you can get. I know that SparkFun Electronics has a lot of choices there as far as chargers and batteries. Definitely worth looking into. Check the Arduino forums on the Arduino website too for people's experiences. So another question, can I ask the Arduino team to make a special board for my projects? They're pretty busy with what they do, so I can't speak for them. But there is software that will help you with their design. Somebody in the chat can correct me if I'm wrong, but I believe the Arduino designs are done in Eagle, and so you could just download those, load them up in the free version of Eagle. On the other hand, the design is so simple that if there's a design tool that you want to use, that you prefer to use, you can just basically clone the design and do it like that. Is it what are some of the most extreme examples, applications you've seen with the Arduino? In the interest of keeping things moving, actually I'd like to ask folks who are still in the chat to answer that. What are the most extreme things you've seen with Arduino? And if you have a link, please post it. I do know that there's a link going around for someone whose web server died, and they switched over to an Arduino to take its place. It's not easy for me to type and switch over and talk at the same time, so if folks who know some really cool Arduino projects can fill up the chat, I'd appreciate it. The other question is it safe to connect the processor pin directly to 5 volts? And there is a certain level of tolerance. I don't know how much beyond 5 volts it tolerates, but whenever there's any question, I'd suggest using either a resistor, or there are some boards that will do level shifting. I know SparkFun has a level shifting board where a logic level converter, the type of thing you want is a logic level converter. So if you've got, let's say you've got something with 13 volts and you want to connect it, you need some kind of logic level converter. Similarly, if you wanted to have the Arduino send signals to a board like the Beagle board, for example, which I think is 1.8 volts, you don't want to send 5 volts to that, or you'll fry it. And the last question in the note that I see is, do I need a grounding kit to work with this, or is it pretty robust? I've never seen the need for any grounding. If you were in a very high static environment, you'd want to rethink that. If you were in a really extreme environment, it might even be the case that you should be using something like a programmable logic controller, a PLC, that's designed for heavy-duty industrial situations where they're getting splashed and zapped all the time. So, and I think that's it for now. I'll stick around in the chat, and there's some good comments in there. I'm looking forward to reviewing the chat transcript myself. I've been learning a lot as I go, actually. And there's a question about the chat window. Catherine, do you know if that can be saved?
Yeah, it's not quite that simple, because there's something like a 50,000 character limit in the chat room. So what I have to do, you can copy and paste, but it's not the entire chat. So what I have to do is go back to the archive playback and pull it from there, and I will do that. So if anyone wants a copy of it, just email me and give me time to do it, because I have a busy day. It'll probably be later at the end of the day. Just email me at webcast@o'reilly.com, and I'll send you a copy of it.
All right, thanks. So should I switch off audio and just go to keyboard mode now?
Yeah, I wanted to say, great webcast, Brian, and I want to thank everyone else who joined in today. This was really great crowd, and I enjoyed it a lot, and I don't even know much about Arduino. So thank you to everyone, and thank you, Brian. And so
Thanks.
Yeah, let's turn off the audio, and I'll let people chat here till about 11:20 or so, and then I'm going to need to get ready for the next event, so I'm going to have to cut it out. But thank you, everyone. And you'll get an email afterwards with a link to our survey, and I do hope you'll take the survey and give us some feedback so we can plan for more of these. Would really appreciate it. And later today, you'll get another email with a link to the recording. Thanks, everyone. Bye.
Thanks. Bye-bye.